So I want to look at multiplication in all the different strategies that are part of our standards. So we're going to look at first an area model and solving this using an area model. We're going to look at an array, we're going to look at partial products, and then we're going to connect them all to the standard algorithm. So I started by building 32, and I need 5 groups of 32. So I need you to remember that when second graders move to third grade, all they've talked about in terms of multiplication is groups of. So they've talked about 2 groups of 4 or 3 groups of 5. They talk about it in terms of groups, not in terms of multiplication. So in this case, I could connect to their prior learning by saying, this is telling me I need 5 groups of 32. And I could have them build that. There's another group. There's 2 groups. I'm going to make sure I keep it where you can see all my groups. There's 3 groups. Here's 4 groups and 5 groups of 32. So then I could talk about, well, now how could this model help me solve this problem? Well, if I join all the 10s together and then I join all the 1s together, I would be able to see the answer to this problem. So let's do that. Let's put all of our 10s and then let's put all of our 1s. So now this looks more like I'm coming closer to an answer. So let's count them. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to slide those apart a little bit because we know 10 tens is equal to 100. Then I have 11, 12, 13, 14, 15 tens. And I have 2, 4, 6, 8, 10 ones. What do I know about 10 ones at this point in my learning? I know that 10 ones is equal to a 10. So I could have them shift this over. Here's my 10 ones. I could have them shift this to the tens column. And if it would make it easier, if they've moved to that understanding, I could just use a 10. So now I know I have this as my answer. Well, 16 tens is one way to say the answer to this problem. But there's a more standard way to say that, which would be 100. I could help them see that if they're still struggling with that place value understanding of 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And if they were ready, I could say, if this is equal to 100, what could we do? Well, we could say these two are equal. 100 is equal to 10 tens. So now I have an answer, 106 tens. So I know that is 160. Okay, that's one way to do it, by building it. Now let's talk about what that looks like if I use this model. If I break this apart by its place value, then I could say 5 times 30, which is 150, or if I needed to help them with that, I might not know 5 times 30, but I do know 5 times 3 tens, and that would be 15 tens. So I can help them break those numbers apart to remind them of that understanding that they already have and make this a little bit easier. So 5 times 3 tens is 15 tens, or 150. Then 5 times 2 is 10, and if you think back to what we built, we had 150 when we grouped them all together, and we had 10. And then we added them together, and we got 160. Then that progresses to the standard algorithm. So I'm going to move this and write that over here, where I learn that this is the ones place and this is the tens place. So I'm multiplying 5 times the ones place, which is exactly what I did here. I need to make that connection. And I can come over here and write 5 times 2 is 10. That's what I did right here. 5 times 2. If it helps them, I could write that this is 5 times 2. And then I could come over here and say, well, what else do I need to multiply 5 times? I need to multiply it by this 3. But what's that 3 worth? It's worth 30. So I'm multiplying 30 times 5, which is the same thing I did right here. And 3 tens times 5 is 15 tens, or 150. And then I can add those together. I progress to the standard algorithm when I'm ready to say 32 times 5. I multiply by the ones place. 5 times 2 is 10. I can't put a 10 here. The 10 has to shift over. That's where we shifted those 10s and made it into another set. And 5 times 3 tens is 15 tens, plus one more 10 is 16 tens. So I need to go through this progression to understand how an array is going to look, how an area model is going to look with partial products before I go to the standard algorithm. So let's see what that looks like with a 2-digit times a 2-digit number. So here's where I need my kids to understand that it would not be reasonable for me to build 24 groups of 15 or 15 groups of 24. That's not reasonable, but I can still work with my strategies that I know by breaking these numbers apart and seeing what am I really working with. So if I draw this out, I can still show them an array. I'm going to build one of the numbers up here, 24. I didn't draw my line long enough. And I'm going to build my other number here, 15. Okay, then I'm still going to look one place at a time. What is 10 times 10? 10 times 10 is 100. What is 10 times this 10? 10 times this 10 is another 100. What is 10 times 1? 10 times 1 is 10. What is 10 times this 1? 10 times this 1 is 10. What is 10 times this 1? That's still 10. And 10 times this 1 is 10. So I've multiplied the 10 times every part, this leads to partial products, times every part of 24. Now I need to do the same thing with the rest of 15, or these ones. So I'm going to do the same thing. 1 times 10 is 10. 1 times this 10 is 10. 1 times this 1 is 1. 1 times this 1 is 1. 1 times this 1 is 1. And 1 times this 1 is 1. And I need to do that same thing 5 times for each of these. So for the sake of time on our video, I'm just going to build it. You would work through that with your kids to help them understand those steps until they were ready to move past having that conversation for every single one of these ones, and they could show you that they could build it. So what I'm really wanting them to see is this is 10 times 24. This is 1 times 24. This is 1 times 24. This is 1 times 24. Do you see how that works in our model? That's what we need kids to understand. Then if we put all of this together, once I finish getting my units there, if we put all of it together, then we have our answer. So I could look at how many hundreds do I have? I have 2 hundreds. How many tens do I have? Well, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 tens. So right now, seeing where I have room to write this, maybe up here. Right now I have 2 hundreds plus 14 tens, and 14 tens is 140. If they need that support, we could count them by tens, 10, 20, 30, 40, 50, and we would prove that that's 140. And then I have an array here of ones that's 4 times 5. I have a group of 5, a group of 5, a group of 5, a group of 5. I could count by ones. I could also count by 5s, 5, 10, 15, 20. And then I'm ready to put my number together to find my answer. So if I added these up, have a 0 here, 6, 360. So that's one way to do it. Now let's look at it with, let me move all of these, with our area model. Let's get all of this out of the way so I have some room to write. So let's break our numbers apart. This time I need 4 boxes, and the kids are going to want to know, why do you need 4 boxes? Because I have 4 digits. I'm working with 24, so that's 20 plus 4, and I'm multiplying by 15, which is 10 plus 5. 20 times 10, they might not be real comfortable with that. But what could I say? 20 is the same as 10 plus 10. 10 groups of 10 and 10 groups of 10. So 10 times 10 is 100. I have another set of 100, so that's 200. Next, 10 groups of 4. I could count by tens if I need to. 10, 20, 30, 40. Then I need to do the same thing with the 5. 5 times 20. What if I don't know that? Well, 2 tens times 5. Well, 5 times 2 is 10, and that's 10 tens. So 10 tens is 100. 5 times 4, there's my 20, and then I can add them together. And I need them to see this connection from when we built it. Here's when I multiplied this part of our model. Here's where I got all my tens when I multiplied this part of the model. Here's where I got my ones when I multiplied this part of the model. And if I added it all together, I would get the same answer. Now let's look at it as partial products written a little closer to the standard algorithm. So if I wrote 24 times 15, the first thing I'm going to do is come over here and write 5 times 4. 5 times 4 is 20. Got it. How about 5 times 20? That's 100. Can I show them that connection here? Yes, please do. Next, I can do 10 times 4. 10 times 4 is 40. Here's my 40. This was my 10 times 4. And then what's left? 10 times 20. Please don't let them say 10 times 2. This is 10 times 20. This was 10 times 20. Is 200. Then when I add them together, just like we've done every single time, I get 360. This moves me to my standard algorithm. And that looks like this. 5 times 4 is 20, but I can't put the 20 here because that's 2 tens. They have to move to the tens place. 5 times 20, or 2 tens, so 5 times 2 tens is 10 tens, plus 2 more tens is 12 tens. Here's where we're struggling. I can't make up some cute way for them to remember to put a 0 here. It's not a smiley face. It's not a funny little song. This is a 0 here because I'm multiplying times 10. That's why I need them to see the parts of this. This is 10 times 4. This is 10 times 20. So 10 times 4 is 40. And then I have 1 10 times 2 tens is 20 tens. Then I can add them together and have my answer. So I need them to see how all of these parts connect to the model that we built with place value blocks, how that connects to our area model, how it connects to our partial products, and how it connects to our standard algorithm. They need to see that progression with a problem so they see all the connections that we make.